Hello everyone and welcome to today's session on what is database schema. The origins of databases may be traced back to the first two computerized examples. In the early 1960s, Charles Bashman created the first computerized version of database. The Integrated Data Store or IDS was the name given to the first database. This was quickly followed by IBM's information management system. The database schema is a database structure expressed in a formal language that is supported by database management system. The term schema refers to the data organization as a plan for how the database is built, means it is divided into database tables in case of the relational databases. Before we move on further and discuss today's agenda, please do not forget to hit the subscribe button and click the bell icon.
We are going to start with what is schema in database. Then we are going to study about database schema and database instance. Then we are going to learn about types of schema in database. Moving ahead, we are going to discuss the benefits of database schema. Later on, we are going to discuss about database independence. And at the end, we are going to discuss about ER model. So, what is a database schema? A database schema specifies how data is arranged in a relational database, including logical constraints such as table names, fields, data types, and the relationships between these entities. Schemas are often used to convey the architecture of a database and serve as the foundation for an organization's data management discipline. This technique of designing a database schema is also known as data modeling. These data models are used by a wide range of people, including database users, database administrators, and programmers. For example, it can assist database administrators in managing normalization operations to avoid data duplication. Alternatively, it can help analysts navigate these data structures in order to perform reporting or other useful business analysis. Within the database management system or DBMS, these diagrams serve as a useful documentation, guaranteeing alignment among numerous stakeholders. Now, let's discuss about difference between database schema and database instance. A database schema is basically the blueprint of a database that explains how data can be related to other tables or data models. However, the schema does not contain any data. A database instance is a sample of a data from a database at a single point in time. It holds all the data values described by the schema. Database instances, unlike database schemas, are likely to change over a time because they are only a snapshot at a specific point in time. Now, let's discuss about types of database schemas. While the term schema is used generically, it usually refers to three main forms of schema: conceptual database schema, logical database schema, and physical database schema. If we talk about conceptual schemas, they provide a high-level overview of what the system will contain and how it will be arranged, and which business rules will be involved. Conceptual models are typically generated as a part of early project requirements and gathering process. When opposed to the conceptual schemas, logical database schemas are less abstract. They provide information that explicitly defines schema objects, such as table names, field names, entity relationships, and integrity constraints. That is it, any rules that controls the database. They do not, however, usually use any technical requirement. Physical database schemas offer technical information that logical database schemas do not, as well as contextual information such as table name, field name, entity connections, and so on. That is it. It offers the syntax for creating various data structure within disk storage. Now, we are going to discuss a schema which is known as star schema and also snowflake schema. So we are going to compare these two schemas. Basically what happens, the database tables will always have a primary key or a foreign key in both logical and physical schemas, which will operate as a unique identifiers for individual items in the table. These keys are used in SQL statement to connect tables and create a unified view of data. Schema diagrams are especially useful for illustrating these links between tables, and they help analysts determine which keys to join. There are two further types of schemas that are used in relational database management systems. They are known as star schemas and snowflake schema. While the diagrams of conceptual, logical, and physical schemas contain different degrees of information about databases, star and snowflake schemas portray these relationship between these things differently. A star schema is a sort of a relational database schema that consists of a single central fact table surrounded by dimension tables. When compared to the snowflake schema, this is considered a simpler schema. A snowflake schema is made up of one fact table that is linked to many dimension tables, each of which can be linked to another dimension table via many to one relationship. This structure has the advantage of little data redundancy, but it is less effective in terms of query performance. A star schema, as the name says, resembles star, where snowflake schema resembles a snowflake. Now, let's discuss about the benefits of a database schema. Database objects and schemas are crucial to ensuring efficiency in day-to-day company operation. As the big data grows, relational models that are inadequately organized and documented will be more difficult to maintain, causing challenges for both the users and the firm. Among the many advantages of database schemas, few of them are: the first one is the database schema designs aids in the organization of data into different entities, making it easier to share a single schema throughout another database. Administrators can also manage or access via database permissions, providing an additional degree of security for particularly sensitive data. A single schema, for example, may contain personally identifiable information, which you would want to encrypt for privacy and security reasons. If we talk about the second benefit, we have organization and communication. Database schema documentation allows for greater organization and improved communication among internal stakeholders. It enables users to grasp the logical restriction and method of aggregation across tables, since it gives a common source of truth. If we talk about the third one, it is integrity. This organization and communication will also contribute to the authenticity of the data. It can, for example, assist administrators in managing normalization operations to aid data duplication. It can also aid in the monitoring of the constraints in the schema database architecture, allowing for the adherence to the ACID principle, which is atomicity, consisting, isolation, and durability. Now, let's discuss about what is database independence. In addition to user data, a database system typically holds a large amount of data. For example, it saves data known as metadata to make it easier to find and retrieve the data. Once a set of metadata is recorded into the database, it is difficult to edit or update it. However, when a DBMS grows in size, it must evolve to meet the needs of its customers. If all of the data is dependent, it will be a time-consuming and a hard task. Metadata has a tiered architecture, which means that changing a data at one level does not affect the data at another. This information is distinct but related. Let's discuss about independence of logical data. Logical data is a database data. It stores information about how data is managed within the database. For example, a database table, a relation with all of its constraints applied to that table. If we talk about the second, we have logical data independence, which is kind of a method that frees itself from the table format and the data on the disk, and it also will not get affected. Let's discuss about independence of a physical data. All of the schemas are logical, and the actual data is saved on the disk in a bit format. The ability to update physical data without affecting the schema or a logical data is referred to as physical data independence. For example, if we wish to update or improve the storage system itself, such as replacing hard disks with SSD, it should have no effect on the logical schema. Now, let's discuss about the entity relationship model. The ER model defines a database conceptual view. it is based on the real-world entities and their relationships. The ER model is regarded as a solid alternative for designing databases. So, if we talk about the ER model consists of the following things: the entity, attributes, keys and entity sets, relationship, and cardinalities mapping. So, let's start with the first one, that is entity. An entity can be any real world item, alive or inanimate, that can be identified. Students, professor, classes, and the courses provided, for example, can all be considered as entities in a school database. All of these entities have some attributes or properties that define them. An entity is a collection of entities of basically comparable types. Entities in an entity collection may have attributes with similar values. For example, a pupil set may include all of school's students. Similarly, an instructor set may include all of school's teachers from all faculties. Entity sets do not have to be disjoint. Let's discuss about attributes. Attribute categories. We have simple attribute, composite attribute, derived attribute, single value attribute, and multi-value attribute. If we talk about the simple attribute, these are the atomic values that cannot be subdivided any further. For example, a student phone number is the atomic value of 10 digits. Let's discuss about the composite attributes. Composite attributes are constructed from more than one simple attribute. A student full name, for example, may include the first name and the last name. Let's discuss about the derived attribute. Derived attributes are the attributes that do not exist in the physical database but whose value are derived from the attributes in a database. For example, the average salary in a department should be determined that saved directly in the database. Another example I can take is of age, which may be calculated using the data of the birth. So, it comes under the derived attribute. Let's discuss about the single value attribute. A single value attribute with a single value characteristics only have one value. For example, the social security number. Let's discuss about the multi-value attribute. Multi-value attributes can have several values, and individuals, for example, can have multiple phone numbers, email addresses, and so on. Now, these attributes can be combined in the following ways: the simple single-valued attributes or simple multi-valued attributes, composite single-valued attributes, composite multi-value attributes. So these are the few combinations we can make in the attributes. Now, let's discuss about keys and the entity set. A key is an attribute or a group of properties that uniquely identifies an entity inside a set of entities. For example, a student's roll number makes him or her identifiable among other pupils. If we talk about a superkey is a collection of properties, one or more, that collectively identifies an entity in a set of entity. If we talk about a candidate key is a minimum superkey. There may be more than one candidate key in the entity collection. A main key is one of the potential keys chosen by the database designer to identify the entity collections uniquely. Let's discuss about the relationship. A relationship is a connection in the association of entities. An employee, for example, works in a department and a student enrolls in a course. Works at and enrolls are referred to as relationship in this context. Let's discuss about the relationship establishment. A relationship set is a collection of comparable types of partnerships. A connection like entities can have properties, and these properties have some descriptive qualities, such as their relationship strength. The number of entities involved in a relationship determines the relationship. Let's discuss about the cardinalities mapping. Cardinality denotes the number of entities in one entity set that can be linked to the number of entities in another entity set via a relationship set. And these can have the following relationships: one-to-one, one-to-many, many-to-one, or many-to-many. So, a one-to-one means that one entity from one entity A can only be associated with one entity from B and vice versa. If we talk about one-to-many, a single entity from entity set A can be associated with several entities from entity set B, while an entity from entity set B can only be associated with one entity. If we talk about many-to-one correspondence, more than one entity from set A can be associated with just one entity from entity set B, while an entity from entity set B can be associated with many entities from entity set A. If we talk about many-to-many relationship, one entity from set A can be linked to multiple entities from set B, and this can go vice versa. This was all from today's session. Hope you would have got some insight regarding what is database schema.
Just a quick info, guys. Intellipaat provides Microsoft SQL certification training in partnership with Microsoft. The course link of which is given in the description below.